This is the first in a series of annual films depicting the development of the F-101A Voodoo fighter plane. The period covered extends from the inception of the airplane to December 31st, 1954. A single-place, twin-engine, high-performance fighter, the Voodoo was designed to support strategic bombardment aircraft by escort and high-speed delivery of special stores on long-range intruder missions. The F-101A Voodoo was developed jointly by the United States Air Force and the McDonnell Aircraft Corporation of St. Louis, Missouri. The McDonnell plant covers 2.5 million square feet of floor area and employs approximately 13,000 people, over 2,000 of whom are assigned to the Airplane Engineering Division alone. Design of the Voodoo was based largely on aerodynamic parameters of an earlier model, the XF-88A seen here on the left. The XF-88A flight development program started at Edwards Air Force Base in 1948, and the test airplanes accumulated 527 flights totaling approximately 458 hours. In 1949, 1950, and 1951, McDonnell engineers and pilots were busy with flight and laboratory tests of the XF-88A. Much of the data obtained were used to establish design criteria for a production version of the airplane. Of the various proposals submitted to the United States Air Force, the model F-88K was selected as the production configuration of the Voodoo. This version, equipped with Pratt & Whitney J57 engines, was redesignated the F-101A. McDonnell received a contract for engineering and tooling of the F-101A Voodoo in January 1952. The first engineering personnel were assigned to the F-101A project in January 1952. Their job was to accomplish various design changes necessary for the new production configuration. For example, the tail assembly was redesigned to include a stabilator, and the mean average thickness ratio of the wings was to be reduced from 7.8 to 6.4% of the chord. Preliminary model specifications were submitted to WADC for review and comment in February 1952. Work began on production design layouts in March 1952, and the first production drawing was released in July 1952. In July 1952, the mock-up board review was held at the McDonnell plant in St. Louis. Later, in August 1952, officers from the Air Research and Development Center at Baltimore, Maryland, reviewed the F-101A mock-up. Signing of a production contract for the F-101A Voodoo was announced on 12 September 1952. In November 1952, United States Air Force officers and McDonnell engineers reviewed the cockpit lighting mock-up of the Voodoo. In July 1953, members of the F-101A Development Engineering Inspection Team assembled at McDonnell. Mechanics are shown here demonstrating engine installation. The engines in the Voodoo are readily accessible to maintenance crews. Meanwhile, actual production of the first 31 F-101A airplanes was advancing rapidly. In the spring of 1954, the assembly line began to take shape. These airplanes were scheduled for an accelerated flight test development program, which would assure that subsequent production aircraft would be well proven prior to delivery to squadrons. In August 1954, a Voodoo airframe was installed in a 150-ton jig in the McDonnell Physical Test Laboratory. and tests were begun to determine structural integrity and to verify the structural loads analysis. Loads encountered during any phase of ground or flight maneuvering were reproduced on the strength test airframe by a complex system of static loading equipment. Continuous checks, both visual and by electrical resistance type strain gauge instrumentation, were made throughout the tests for indication of approaching specimen yield or failure and for areas of possible structural instability or weakness. The number 1 Voodoo was loaded aboard 2 Air Force C-124 Globemaster cargo airplanes and flown to Edwards Air Force Base in California on the 23rd of August, 1954. At Edwards, it was reassembled and prepared for flight. While the Voodoo was being made ready for flight at Edwards, jettison and pressurization tests of the canopy installation were conducted at McDonnell. Near the end of August 1954, the canopy was jettisoned successfully, and the canopy emergency system was structurally cleared for flight. The canopy is equipped with a diaphragm-type seal. It utilizes an M1A1 catapult and is jettisoned in flight by pulling one or both seat leg braces. Functional tests of the pilot ejection seat were conducted using a 300-pound dummy fired from an F-101 fire test nose assembly. The Voodoo uses the North American-designed F-86D type ejection seat with an automatic quick-opening safety belt. These initial tests proved the structural and functional adequacy of the seat installation. On the 29th of September 1954, only 37 days after it arrived at Edwards for reassembly, the F-101A Voodoo was ready for its first flight. R.C. Little, McDonnell's chief test pilot, is shown here boarding the plane. This flight initiated phase 1 of the accelerated test program. The power plants of the number 1 Voodoo were XJ57 P-13 engines. They delivered a total of 28,000 pounds of thrust using afterburners. The J57 engines are equipped with type MB3 pneumatic starters to operate in conjunction with MA1 pneumatic ground starter equipment. Supersonic speeds were attained on the first flight of the Voodoo, and the pilot reported excellent climb performance and handling characteristics. The Voodoo was designed with emphasis on performance, good handling characteristics, and easy maintenance. It has a wingspan of 39.7 feet and is 67.5 feet long. The overall height is 18 feet. The wings and stabilator are swept back at an angle of 35 degrees along the quarter chord line. Construction of the fuselage is conventional. The wing skin, however, is of heavy tapered preformed sections. The first landing of the F-101 at Edwards was routine. The landing gear is a conventional tricycle type. Speed brakes are located in the aft fuselage. Low-speed handling characteristics proved excellent on the first flight with a touchdown made at 140 knots. As seen, the landing roll is reduced by use of a parabrake, which is opened by the pilot during the landing rollout. The aircraft has a combat radius of 1,000 nautical miles with a takeoff gross weight of approximately 49,000 pounds. It is equipped with an MB-1 autopilot. Provisions are also made for dual droppable main wheels, which enable the airplane to operate from steel mat fighter strips. Air Force preliminary evaluation began on October 28, 1954, only 29 days after the first flight by the contractor. In this scene, Brigadier General J.S. Holtner of Edwards Air Force Base is shown climbing into the Voodoo. General Holtner receives a last-minute briefing as he settles himself into the cockpit. The Voodoo has two 3,000 psi closed-center hydraulic systems. One system furnishes half the power for the ailerons and stabilator. It also supplies power to the rudder and for emergency flap operation. The second system provides power for all utility services. It also supplies half the power to the ailerons and stabilator. The arrangement is such that each system can provide emergency control in the event of failure of the other. The thrust loading of the Voodoo at takeoff with full internal fuel is approximately 1.5. This results in extremely rapid acceleration and requires the pilot to retract the landing gear immediately after becoming airborne to avoid exceeding the gear down limit speed of 250 knots. The Voodoo carries over 2,000 gallons of fuel internally. Total fuel capacity is over 3,000 gallons, including 900 gallons in 2 external tanks. Firepower of the Voodoo consists of 4 M39 20mm guns, which have a combined firing rate of 6,000 rounds per minute. The guns are installed aft of the cockpit in the lower fuselage, and ejected links and cases are retained. An MA7 fire control system is installed, which includes the Hughes APG-37 radar gear with a 24-inch diameter antenna. An MA1 low-altitude bombing system and an M1 toss bombing system are provided to deliver special stores. The McDonnell-designed drift computer, which works in conjunction with the MA7 fire control system, feeds actual crosswind corrections to the ground position indicator during flight. The electrical system of the Voodoo consists of 2 400-cycle, 3-phase AC generators of constant frequency. The generators are driven by separate Sunstrand constant-speed drives. In all, 5 Air Force pilots evaluated the Voodoo between 28 October and 21 December 1954. These included Major General Albert Boyd, shown here in the cockpit, Brigadier General J.S. Holtner, Colonel F.K. Everest, Major James Butler, and Captain R.J. Herrer. Colonel F.K. Everest is briefed for his first flight in the Voodoo. From the day of the first flight by the contractor on 29 September 1954 until 21 December 1954, a period of only 11 weeks, Air Force and contractor pilots accumulated approximately 61 hours of flight time. A total of 56 flights were completed. As the year 1954 ended, the Voodoo was well started on its accelerated development test program. The 61 hours of test flying showed the Voodoo to have exceptional takeoff and climb performance. Aeroelastic stability was found to be satisfactory throughout the range of Phase 1 tests. On December 18, the airplane attained 1.45 Mach number in level flight at 40,000 feet. On 24 December 1954, the Voodoo reached 49,500 feet and was still climbing at 1.22 Mach number when the run was discontinued because of engine stalls. Engine stalls proved to be the major deficiency during early tests, although there was some improvement with redesigned air inlet ducts, which were installed near the end of the Phase 1 program. During the Phase 1 tests at Edwards, pilots reported that airplane handling at low speeds was good. Patterns were flown at 200 knots with 160 knots on final. Over-the-fence speeds were generally 135 to 140 knots, and touchdown speeds ranged from 126 to 140 knots. In one case, with a gross weight of about 33,000 pounds, the Voodoo used only 3,400 feet of runway during the landing rollout. Air Force test pilot Major James Butler prepares for a flight in the Voodoo. The Voodoo handles easily on the ground, and pilots reported excellent vision from the cockpit during taxi operations. Early tests demonstrated that the Voodoo can take off in 2,500 feet with a gross weight of approximately 33,000 pounds, or in 2,100 feet with a gross weight of about 32,000 pounds. Pilots reported that climb performance of the Voodoo was spectacular, being limited only by engine compressor stalls. One climb was made at maximum power by climbing at subsonic speeds of 0.93 to 0.94 Mach number to 35,000 feet, and then climbing at supersonic speeds of 1.22 to 1.25 Mach number to 46,500 feet. In another test, a climb was made to 40,000 feet in 2 minutes and 45 seconds from time of brake release on takeoff. At the close of the initial evaluation in 1954, Air Force pilots generally agreed that in addition to the major problem of engine compressor stalls, the following items needed improvement or correction. 1. Erratic operation of engine bleed valves. 2. Tendency of fuel controls to drift. 3. Failure of afterburner nozzles to return to full closed position following afterburner shutdown at medium and high altitudes. 4. Frequent failures of the Sunstrand constant speed drive units. 5. Excessive sensitivity of the ailerons under certain flight conditions. 6. High nose gear forces while taxiing. 7. Unreliability of cabin air conditioning. And 8. Inadequate arrangement of throttle quadrant components. Means to improve these deficiencies were investigated by McDonnell, and corrective action was scheduled for early 1955. As of December 31st, 1954, at the end of the initial evaluation, the general conclusion was that the F-101A was an aircraft of superior performance and operational versatility, limited in potential mainly by engine compressor stalls. Pratt & Whitney, manufacturer of the J-57 engines, initiated studies to improve the stall condition from the standpoint of the engine. Meanwhile, McDonnell began an intensive engine duct improvement program to improve the stall condition and simultaneously began studies of alternate engine installations.